Hello once and teachers, my name is Takyan Setha and I come from group I3 5D, and today we will talk about Project 1, which is Traffic Light Controller. Our team include five members, which are Takyan Setha, which is me, Sring Sophia Kanya, Tang Nakri, Tak and Soksana. Here's our table of contents. Move to point 1, Introductions. These projects involve designing a traffic light controller for a four-way intersection using circuit words. The main objective is to simulate an organized and realistic traffic signal system that manages vehicles' movements in a cyclic sequence. The controller is allow straight right and left turn in the separate phases for each road, top and bottom, left and right, and use a sequence display segment to show countdowns for each phase, and the goal is to demonstrate how logic and state machines can be applied to solve real-world traffic control problems. To point 2, which is circuit overview, and the picture is coming from the traffic light mains of our projects. Key part is counter, clocking unit, state decoder, controller, and segment display. And function is that is counter countdown time, state change after each cycle, lights and display update based on the current state, and the cycle repeat to manage traffic flow. Detailed explanations. Counter 0 to 60. A digital timer that counts up to 60, and it tells the circuits when to change to the light phase. It is changed when the number count to number 35, 40, 55, and 60. And for the reasons it's triggered at that time because of our type. So we going green for 35 seconds, then yellow for 5 seconds, and then going left green for another 15 seconds, and going to left yellow for 5 seconds, and then going to red for which both for the four of them include equal 60 seconds, and which is also the state of the red the light red too, and the cycle is repeat for road B as well. So let's go back to our presentations. Clocking is a small circuit that stores number state from 0 to 7. It changes the next state from S0 to S7 when triggered. It just counts the number from 0 to 7 in binary number. State controller decoder. It's take the binary number from clocking, and it will decode which state it is in right now, and it starts from 0. When the number is 0, the state is 1, and when the number change, it will increase from state 1 to state 7. State controller, it's just like when it is state 1, which light should be turned on according to this truth table. Like in state 1, it is A key 1, L or 1, B or B red 1, and B left red 1. And when it changes to S1, the A key will change to AY, and then after that to red, and another to green. The state is just for controlling the light. And this display road, it just integrated both from road A and B together. It just to show so the problems and the counting. Here, let's go to our demonstrations. Right now, the light starts when this is 39 and 59, which will move down to 0 and 39 will move down to 0, and after that it will going into another state which is 19, because we include both the yellow inside the number counting as well. Let's turn it on. When we turn it on, we see that the number load. Let's speed up it a little bit. Green, and after that it will go into red. Boom. Green, the left turning left turn green, and also both the upper side as well. It's just that when the trigger, here is how it works. The clock will, which is also connected to enable, when both of them are true, it will trigger the clock, and when it is triggered the clock, it will trigger the display rod which count down the number, and also counting up the counter 60. So when it is count to 35, it will enable the clocking, which is increase the number by 1. When it is increased number, it will change states. Right now it is in state 4, and then it changed to state 5, which also change our LED light. This now in conclusions. The logic summary and outcome is that design and stimulate a traffic light controller for a four-way intersections using circuit. The system use sequential logic, counters, and state machines to manage traffic flow through 8 well-defined phases, include straight, right, and left turns. The key outcome is that building a working state-based traffic controller uses one 6-minute display to show the countdown timer for better time awareness, gain practical experience in digital circuits design and simulation. This project was a great hand-on experience in applying digital logic to solve real-world problems. It includes how components like counters, decoder, and control logic come together to form a complete system. It also helps develop a deeper understanding of how traffic light logic is organized in real city, how importance of timing, sequencing, and state transition, and how simulations can be used for testing design before real-world implementation. In the future, the system could be expanded to include sensor, pedestrian signal, or adaptive traffic control based on real-time reports. Here is our member and the responsibility. Thank you.